When you're solving systems of equations. We're going to start in this video by illustrating the two of the methods you can use to solve these 2x2 systems with. The first method is called the substitution method. If we're using the substitution method, here's a good example. 3x plus y is equal to 14. X minus 2y is equal to 0. In the substitution method, the idea is that we're able to, through substitution, create an equation with a single variable in it so that we're able to solve for one and then plug in and solve for the other. Here's how it works. In one of the equations, solve for one of the variables, and looks like in the second one I can get the x very quickly all by himself. We're going to get x is equal to 2y. Now that little block is what x is equal to, so now everywhere in the other equation that there is an x, I'm going to replace it with that little block. So we get 3 times 2y plus y is equal to 14. Now look what that's created. I've got an equation with nothing but y in it. I'm able to solve for y now. So we're going to clean them up. 6y plus y is 14. 7y is 14, or y is 2. Now, in these 2x2 systems, all of our answers are in the form of a point. So having found the y value, I can now go back to my little substitution block to help me find the corresponding x. X will be equal to 2 times y, which I know is 2, so I'm going to plug that in. So my x is 4. Let's look at the second method. It's the elimination method or addition method, depending on your textbook. When you're looking at the elimination or addition method, the same concept is there. You want to be able to create an equation with a single variable in it so that you're able to solve for it. With x's and y's, you just can't do that. We have to create an equation that has only x's or only y's in it. With the elimination process, we want to be able to add them and have one of the variables cancel out that way. I'm looking at the 5 and the 2. You can do either variable, it doesn't matter. I'm going to eliminate the x's here by creating a 10x here and a negative 10x in that position. I can do that because I'm able to multiply one or both equations by constants to make them look the way I need them to. To get a 10x in the first position, I'm going to multiply that entire first equation through by 2. To get a negative 10 in the second equation, I'm going to multiply him all the way through by a negative 5. So I have 10x plus 6y is equal to 36. I have negative 10x plus 35y is equal to positive 5. So now when I add them together, the x's cancel. That's what I want to happen. And I have 41y is equal to 41. An equation now with only y's in it, which will enable me to solve for him. I divide both sides by 41, and so y is 1. Now keep in mind, all of the answers in this section are also in the form of a point. So having found the y value, we now need to find the corresponding x value. I'm going to go back up to one of the original equations. I can use either one. I like the second one only because the numbers are a little bit smaller, but both of them will generate the same corresponding x value. We have 2x minus 7y, which is 1, equals negative 1. So now we have 2x minus 7 is negative 1. 2x will equal 6, and finally our x is 3.